Hey, 8th graders, welcome back. Get ready, because today we are embarking on week 9 of our deep dive into the properties of water. I am so thrilled to guide you through today's explainer, where we're going to look at water in a way you've probably never seen it before. You know, we drink it, we swim in it, we wash our hands with it every day. But have you ever stopped to wonder how water actually holds itself together? Today, we are exploring the liquid grip, specifically the invisible, totally fascinating forces known as surface tension and capillary action.
To anchor our lesson today, let's look at this incredibly powerful verse from Psalm 89:9. It says, "You rule over the surging sea. When its waves mount up, you still them." Now, when we think of God's design and power, we so easily picture massive, crashing ocean waves, right? But what's truly mind-blowing is that this grand order over the massive oceans extends all the way down to the microscopic level. The exact same design that stills the surging sea also governs the tiny, invisible behaviors of a single drop of water resting quietly on a leaf.
Okay, let's dive into this. Here is our roadmap for the day. First, God's order over water. Then, unlocking surface tension, followed by understanding capillary action. After that, we'll look at science in the real world and wrap things up with morality, education, and peace. Let's get started.
Jumping right into part 1, God's order over water, extending down to its absolutely smallest behaviors.
So we're shifting our focus away from the massive crashing waves and zooming way in on the absolute smallest behaviors of water molecules. Because to understand the big stuff, we have to master the tiny stuff first. Before we can talk about water acting like a stretched skin or climbing up narrow tubes, we really need to understand the two main forces at play here. First up, we have cohesion. This is when water molecules bond to other water molecules. Think of it like water giving a giant bear hug to more water. Then we have adhesion. This is when water molecules bond to other surfaces, like the glass of a cup or a blade of grass. Think of adhesion as water holding hands with something that isn't water. So remember, cohesion is water to water. Adhesion is water to something else. Make sure to lock those two terms in your mind.
Moving right along to part 2, unlocking surface tension, or as I like to call it, the stretched skin of water.
Have you ever slightly overfilled a glass of water and notice how it kind of bulges at the top without spilling over? It literally looks like there's an invisible dome holding it all in. Well, that is surface tension. It's a film or a stretched skin created when surface water molecules bond tightly to neighbors beside and below them. Imagine you're in the middle of a really crowded room, holding hands with people on all 4 sides of you. You're being pulled equally in every direction, right? That's what water molecules inside a cup experience. But the molecules right at the very top surface, they don't have anyone above them. Because they have fewer neighbors, they grip the neighbors beside them and below them much tighter. This intense cohesion at the surface creates a physical barrier, a film strong enough to actually support light objects.
All right, part 3, understanding capillary action, defying gravity in narrow spaces.
So we've seen how water creates this tight skin, but what happens when water encounters a really narrow space? Believe it or not, it can seemingly defy gravity. Capillary action is defined as water climbing narrow spaces due to cohesion and adhesion working together. And this brilliantly illustrates teamwork at the molecular level. Here's exactly how it happens. Adhesion makes the water molecules grab onto the wall of a narrow tube, pulling themselves slightly up the side. But because water also has cohesion, those molecules drag their fellow water molecules up right behind them. Grab the wall, pull your buddy up. Grab the wall, pull your buddy up. This incredible combination allows water to climb upward all on its own.
Which brings us to part 4, science in the real world. Bugs, plants, and technology.
It's one thing to talk about microscopic molecules holding hands, but it's a whole other thing to see how this actually impacts bugs, plants, and even human technology. First, think about the paper towel soak. If you dip just the very corner of a dry paper towel into a puddle, the water climbs right up. Adhesion pulls the water to the paper fibers, and cohesion pulls the rest of the water along for the ride. Second, look at the water strider insect. It literally walks on water. Its specialized legs spread its weight out so perfectly that it doesn't break those tight, cohesive bonds of the surface tension. It just rests right on that stretched skin. And third, human engineering actually borrows this very design for medical test strips, which move fluid without any machinery at all.
Let's actually zoom in on that last one, because it is absolutely brilliant. How do engineers use capillary action in healthcare, like in a blood glucose test strip? Step 1. The tip of the strip touches the liquid.
Step 2. Microscopic, narrow channels inside the strip use adhesion to grab the fluid. Step 3. Cohesion pulls the rest of the liquid right through the channel. All of this happens mechanically, without a battery, without a motor, and without a pump. We are simply borrowing the incredible physics of water to build life-saving technology. How cool is that?
All right, 8th graders, it is time to switch gears for a homework rapid fire. Sit up straight, clear your mind, and let's test your knowledge to see if these concepts have truly stuck. I'm going to ask a question, and I want you to answer it out loud before I reveal the answer. Ready?
Question 1. How exactly does cohesion cause surface tension? Think about those molecules at the very top of the water. What is totally unique about their situation?
Boom! Surface molecules have fewer neighbors, so they bond super tightly to those beside and below them. If you remembered the fewer neighbors rule, fantastic job. That tight bonding is exactly what creates that incredible surface film.
Next question, what is one example of capillary action happening naturally in plants? Think about how a massive tree gets a drink of water all the way from the ground. That's right, moving water upward in plant roots and stems. The water adheres to the narrow tubes inside the plant, and cohesion drags the rest of the water up, fighting against gravity all the way to the top leaves. Great job!
And that brings us to our final section, Morality, Education, and Peace, the HeroesmartAcademy philosophy. We've learned some really fascinating science today, but how does this knowledge actually shape who we are? Well, we look to this promise from our source material, Romans 8:6-7, promises peace of mind to everyone who keeps his or her mind spiritual. You see, just as there is an undeniable, invisible order to the physical universe, like those cohesive forces holding a water drop together, there is an invisible spiritual order to our lives. Recognizing the intelligent design in a simple glass of water is a stepping stone to experiencing that spiritual peace of mind. The overarching philosophy here is incredibly important for us to grasp. Education without morality will hurt. Think about it. What is the point of being incredibly smart, of knowing the complex physics of capillary action or surface tension, if we just continue to make bad choices that hurt ourselves and hurt the people around us? A sharp mind without a kind and moral heart is kind of like a tool without a purpose. We intertwine our education with morality because knowing how the world works should absolutely inspire us to live better within it. So I want to leave you with this final, challenging thought. You now know the science of water. You understand the liquid grip, cohesion, and adhesion. But how will you use your education, all the amazing facts you're learning, to bring peace to your mind and to your community? Knowledge is power, 8th graders, but wisdom is knowing how to use that power for good. Think on that as you go through your week. Thank you so much for joining me on this explainer. Keep being curious, and I'll see you next time.